here that's kind of erased. Like it's kind of like, what is that? Kind of,
Yeah.
I'm not sure what's going on here. Like if I'm grading it, I'm like wondering, well, what's going on here? The other thing I don't see like this going down forever. On the left side, I do see that. That's good. That would be, this would be problematic, I guess. So, like this can connect here. Like, so what I'm not seeing is the evaluation of like this last one at the endpoint 3. Like what's going on at 3 when you put it into this. Looks like it's there and there's kind of but like you really want to clean this up, I guess is the point. Um, it seems a little bit, but it's just not, you gotta be careful because we don't want you to miss points for not connecting certain stuff like that. And, this one going down and so on. But this is good. Any questions on how to do this before we go to doing one like it or
No.
okay. And do you want it to be this complicated or do you want something?
I prefer easier because I still am trying to
Okay,
learn.
let's just do two pieces then to start here. Let's say f of x equals minus x plus 2 squared plus 4. And we'll say this is good for x less than or equal to 1. And then we'll go 2x plus 1 for x greater than 1. So just keep two pieces here. Now, do you want to try this on your own? Do you want me to kind of guide you through it? What would be best to help you?
Can you guide me through this one?
Sure. Yep. Yep. Very good. Can you tell me what the first one is? What it is the graph of,
Um,
generally speaking?
is it a quadratic?
It's a quadratic, yes. So something U-shaped, something U-shaped. And if you recall, when you're graphing a quadratic, you really want to know what's called the vertex point. Do you remember how to find the vertex from the way this is
Is it 2,
shown?
4?
It is negative 2, 4.
Negative.
So notice it's opposite inside there. So if we're creating a sketch here of this, actually, this probably needs to go up a little bit. So negative 2, 4 would be somewhere like that. Okay. And then the best way to do it is to create a table, which is what I didn't see on there. Now you have to get to this 1. So you might even start at 1, 0, -1, -2, which you already have. And you want to graph these points by putting these numbers in for x. So like you're putting 1 in for x, 1 plus 2 squared, negating it, and then adding 5 to it. Do you want to give that a try to calculating y for this first one?
Yes. The -5 for the first one.
And then we do the same thing for 0. So 0 plus 2 squared is 4. -4 plus 4 is 0. And then why don't you do this next one at -1, please?
So 3 and 4.
Yes, it is 3. Good. So we've got some points here that we can graph. So -1, -5, 1, 2, 3, 4, 5, 0, 0, negative 1, 3. Now, it's important that you recognize that this one is good for x less than or equal to 1, and that it's a filled-in circle there. And then it's kind of coming back going the other direction. Now, you can use symmetry to find the other values, or you can make the table. What do you think you would do on the test or the quiz?
Symmetry.
So by symmetry, there's one there, and then there's one there. And very important is that you show that on the left here that it's going down forever, because it's good for less than or equal to 1. So it's going, down forever the other way. Gotta see those arrows.
Okay.
All right, so whenever you're ready, we'll get to the next piece.
Okay, I'm ready.
So the next piece is good for x greater than 1. This is an equation of a line. And you can make a table again if you want. You could say, okay, I'm going to start at 1, but this time it's an open circle. 2 and 3, maybe graph a couple of points there. You're putting those x values in here and this right here. So could you give me the y values for this, please?
The first one's 3.
Okay.
Second one's 5. The third one's 7.
All right, so 1, 3, open circle. Very important. That one has an open circle. 2, 5, 3, 7. And then you connect the open circle, go that direction. So what it mostly is here is being able to make a table in whatever piece that you're in. And then we can do the rest of the analysis based on this graph here.
Okay.
All right, so let's talk about the domain and range here real quick. The domain actually comes from the pieces right here. The first piece is less than or equal to 1. The second piece is greater than 1. There's no restriction, so it's minus infinity to infinity. The range, that's where you got to look at the graph. You got to see how far down does it go? And this goes down forever. How far up does it go? This goes up forever. So this would be minus infinity to infinity also. And now we can talk about the next two pieces, increasing and decreasing. So increase means it's going up and to the right. But we're looking at the x values now. For increasing, decreasing, it's the x values. So if we scroll back up here, this part where my cursor is increasing all the way up to the vertex, and then it's increasing over here. It's because it's going up and to the right. So we need the x values here. This is at -2. This is at 1. So it's increasing from all the x values up to -2. This goes to the left forever. So it's from negative infinity to -2. So what that is that's all the x values up to -2. This thing is going up and to the right. But then you add to it over here, 1 to infinity, starting at 1, going up forever, to the right forever. It is also increasing. And typically, if it's not increasing, it must be decreasing, which is going down and to the right. And again, these are x values. So decreasing is from, again, the x value from -2 all the way to 1. So it's the x values, not the y values. That's where it is decreasing. And you can see that's the gap between these two.
Is that the only time it's decreasing?
But in this one, I mean, it could be more than one interval. It just depends on the problem. It could be no intervals. You're looking for up and to the right increasing, down and to the right decreasing. These are, note cards, Quizlets, things where you can memorize them that way. Now we could certainly do another problem here, but you've got, a bunch more on your review here. Do you want me to move to 2 and give you some problems like what you see on 2?
Yeah. Yes.
Okay. All right. So let's actually do one that's like 2B next, and then we'll go back to 2A because it's more complicated. Let's say it's the y equals the square root of minus 5x plus 2 plus 3, and put negative 6 out in front. So there's a lot of things here that don't matter. And there's a lot of things. The only thing that does matter is this part inside the root. So for the domain, you set the part under the root greater than or equal to 0. So just the part under the root, which in this case is minus 5x plus 2, you set that greater than or equal to 0. Is that okay?
Yeah.
Now you have to be able to solve this inequality, and that could be problematic. So to do this, there's a couple of options here. You can subtract 2 from both sides, or you can move the minus 5x to the other side. Which way do you see it? There's not a wrong answer, just which way do you see it?
Um, Subtracting 2 from both sides.
Okay, so we're going to subtract 2 from both sides. So we have minus 5x greater than or equal to negative 2. To isolate x, we have to divide by negative 5. Whenever you multiply or divide by a negative, it flips the inequality. So x is now less than or equal to 2/5, like that. So this, if you need to, you can put it on a number line to sort of figure out what the interval is, but there's 2/5, there's minus infinity, there's positive infinity. It's a closed circle. It's everything to the left of it. So your domain here is minus infinity to 2/5 with a bracket like that. Okay. Why don't I give you one to try? Once you get all this down, or if you have questions.
Right.
You ready for it?
Yes.
Okay, so this time I'll just do slightly different notation. G of x equals 2 square root minus 2x plus 6, and put a minus 1 here. A lot of distractions. You're still just going to set the part under the root greater than or equal to 0.
Yeah. Is it x is less than or equal to 3?
Okay. But we want it in interval notation. So we want it like this is correct, but we
Well,
want it in this notation up here. So what would that look like?
um, negative infinity, negative 3, or comma 3,
-3, and then is it a
bracket.
yes, yes, that and that's what they're looking for. Very good.
Oh, it is negative 3?
Yes. I'm sorry, you said +3, didn't you?
Yeah.
I wrote down something different. Yeah, it is +3. Yes. Okay, fantastic. All right, so the other type of problem you're seeing here is where there's something going on in the denominator. Let's say it's like x squared plus 5x plus 4 over 3 square root 2 plus 3x, something like that. Okay. Now, normally you set the part under the root, this part right here, you set it greater than or equal to 0. Okay, but the problem is because it's in the bottom, you set it just greater than 0. And the reason is because you cannot divide by 0. So that's the only difference. You set the part in the root if it's on the bottom greater than 0 instead of greater than or equal to 0, and you still solve it for x. Okay, so could you do that for us, please? Solve this one for x.
Is it x is less than negative 2 over 3?
So tell me, why did you flip the inequality?
Um, because we did last time.
Okay, but this is really important. So like you only flip the inequality when you multiply or divide by a negative. Did you multiply or divide by a negative?
No.
Okay, so that is the only time you flip the inequality. So that has to also be, maybe on a note card, maybe something you just write down. So in this case, x is greater than -2/3, because your answer is completely wrong. Like it's the complete wrong side, and that's why this is such a big deal. It's -2/3 to infinity. This time it's parentheses on both sides because of that greater than.
Okay.
Okay, so let me give you one more to try, if that's okay, before we move on to number 3. Let's say it's a y equals x minus 2 over -4 square root -3 plus 4x. I want you to find the domain, please.
Would it be 3/4 to negative infinity or comma negative infinity?
Do you mean like this? Like this?
Yeah.
Okay, so if you think about where what you're trying to do here on the number, let's just say 3/4 is there. It's always left to right, like the smaller number to the larger number. So this like doesn't make sense. Like it's because the negative infinity would want to come before that. But again, I think maybe there's just an issue with solving the inequality here. So you're setting -3 plus 4x greater than 0. You're adding 3 to both sides. Maybe this is what it looks like you have on your page. You're dividing by 4. Do you have x is greater than 3/4?
Yeah.
Okay, so what that means is it's all the numbers bigger than 3/4. So 3/4 there, infinity's there. Is it to the left or to the right?
To the right.
To the right. So it's all of these numbers. And then the way you write your interval is from left to right. So it's 3/4 to
Infinity.
positive infinity. So if it's greater than, it's to the right. We had a problem or a couple of problems where it was less than. That's to the left. Maybe something else to put on a note card there to remember for tomorrow. Okay, let's look at the next problem here. Let's this one is like 3. Okay, so let's go 5x minus 3y equals 8. All right, we'll just start with this. Okay. Um, we need to first, if you look at number 3, I don't know if you have it in front of you, it says write a line perpendicular to this equation through a point, which I'll give you in a moment, in point, slope, and slope intercept form. So whenever you write an equation of a line, you need the slope. Okay, we need the slope of this equation. Do you remember how to find the slope of something like this that's in standard form?
Um, y equals mx plus b, right?
Yes, so we need to basically solve for y. Solve for y. So to do that here, I'm going to subtract 5x from both sides. And then I think it's best to put that in front. So it's minus 3y equals minus 5x plus 8. Then you divide everything by -3. So like what I'm seeing on your page is I don't see any of the work like this. Maybe it was on the board or something, but definitely would recommend getting a few more steps down next time when you're working through this in class.
Okay.
Uh, so on the right here, it ends up being 5 over 3x minus 8 over 3. What is the slope of this equation?
5 minus 3, or 5 over 3.
Right now, the perpendicular. Do you remember how to find the perpendicular slope from the given slope?
I don't.
So it's called the opposite reciprocal. Does that mean anything to you?
Kinda, yeah.
Okay, so the reciprocal means to flip it, to flip the fraction. And then opposite means to negate it. So if it's positive, it becomes negative. So this is your new slope. Right now, like everything we just did, like we now like we're given an equation, we're done with all that. Like we just needed this number here, which is why we had to do all that work. So it's going to say write the equation in point slope form, and I'm going to give you a point. Okay, I'm going to tell you that it goes through. Let me look at your problem here to see what they did. Yours didn't work out very nicely. Okay, let's go through the point -2 comma 5, like that. Okay. So do you remember point slope form of a line?
No. Or like kind of.
Okay, and I'm just asking because if you know it, it's great. I don't have to go into as much explanation. If you're not sure, say so. That way, I can give you the information here. So this is point slope form of a line. Again, something else to remember. You have to know this. You get a reference sheet for the
Uh,
test.
kind of. She puts them on the top of the test. Like she writes a couple of the equations.
Okay, maybe this one will be on there. So this has a slope and a point. The point is x1, y1. So you have a slope here, -3/5, and you have a point x1 and y1 like that. Is that okay?
Yeah.
All right. So now it's y -5 equals -3/5 x minus a -2, like this. So just follow the mapping. Make sure you say, okay, I see where the slope comes from. I see where x1 and y1 comes from. All right, so this is almost done. Now you do want to combine the signs here. So if you see a double negative like this, you do want to make it positive. And this is done for point slope form, completely done. And you want to start in point slope form because it leads to slope intercept form. If you look on your in-class work there, it says point slope and slope intercept form. Any questions on that before we move on?
No.
Okay, so slope intercept form is the y equals mx plus b. And you'll notice, in other words, it's solved for y. So we have to solve uh, in this problem. So to do that, you first distribute this number in a fraction, which isn't great. I get that. It's not great. When you multiply it in, you multiply a fraction by putting this over 1. You're multiplying the top number and then the bottom number. So it's -6/5 like that. And then the last step here is to add 5 to both sides. And that does solve it for y, but it's not simplified. So um, we have to add these fractions together. So to add fractions, you make a common denominator. In this case, the common denominator is 5. The one on the right becomes 25/5 because you multiply the top and bottom by 5. And I'm doing something that I see similar to what you have in class here. Like I'm not trying to make this harder. This is the style of problem they're giving you in your class there. So this becomes y equals -3/5x plus 19/5. But just to be clear, like these are both the answers to this problem. There's this one in slope intercept form
And then
and then point slope form. Any questions, thoughts on that before we proceed?
no.
Okay. So let me just quickly here. Let's just talk about perpendicular slope. So let's say you figure out but the slope is 2/3. The perpendicular slope is the reciprocal, the flip of this, negated. Okay, so let's say the slope is 5/3. What would the perpendicular slope be in this case?
-3/5.
Good. And let's say the slope ended up being -2/7. What would the perpendicular slope be?
7/2.
7/2. Good. Okay. The only other one here is I'll throw at you is let's say the slope was 3, and 3 is really 3/1. What would the perpendicular slope be?
1/3.
You gotta negate as well. Yeah.
Positive,
So, yeah,
negative.
1/3. Good. Okay, you got it. All right. Now I see another side, a Wednesday. Should we go through stuff like that, or do you want me to give you another problem like this one with the perpendicular line to look at?
Can you do on like Wednesdays?
Yes. Okay. So I see G inverse. Darn. That's really great. Okay, let's do inverse first. So let's say f of x equals 3x² plus 2. And we're asked to find f inverse of x. This means inverse. So there is a recipe. There's a set of steps here to follow to determine the inverse. So the first thing is to replace f of x with y, which doesn't seem like a big deal, but it is important to do the step. It's like preheating your oven, which maybe you heard earlier went off. Like, preheat it, it doesn't get hot. So we need to do this. The second step is to switch x and y. So wherever you see an x, you put a y. Wherever you see a y, you put an x. Something like that. Does this look familiar to you from what you did in class?
Yes.
The next thing, and this is the most challenging, is to solve for y. All right, so to do this, this is where most of the work comes in. So we're going to first rewrite that equation. First, well, let me ask you, what should you do first to get y by itself? What would you undo first over here on the right?
Um, subtract 2.
Okay,
Or
agreed.
no, or
Yep,
yeah.
yep. So you undo addition and subtraction before multiplication and division. Now you undo the 3. So you would divide both sides by 3. And I'm going to flip. So it's going to be y² equals x minus 2/3. And we're almost there. You could sort of say, well, it looks like it's solved for y². Well, it kind of is. How do you undo a square?
Like by cubing it.
So a
Or,
square is undone with a square root. And what
or
you're
that,
referring
that's
to,
what I meant. That's what I.
okay. And a cube undoes a cube root and so on, things like that. All right. So yeah, as long as you write the correct thing, that's all that matters. All right. So this is now your inverse. Step 4 is to replace y with f inverse of x. F inverse of x equals x minus 2/3. Now, in full disclosure, there is a little bit more to this, but probably not worth like emphasizing too much right now because you're so close to the test. But um, there's a bit more here that I'm kind of avoiding talking about. Do you have any questions about what we did on this problem here? Because I'd like you to try one on your own, if you don't mind.
No, okay.
Okay. So let's say, and I'm going to switch it up here. I'm just going to call it g of x instead of fx. No big deal there. And let me go 4x² minus 3. And I want you to find g inverse of x for me, please. So take a minute or two, see what you come up with, and let me know if you have any questions.
So it'd be the inverse of g of x is the, what's the root thing called again? Square root?
Square root, yeah.
Square root and then x plus 3 over 4.
You got it. Good. Okay, very good. Now, the next thing that I could ask you to do is to find the inverse of a certain number. Like I could ask you to find the g inverse of, let me pick something here that works. That's not too bad. Sorry, I'm losing my mind here. Let's go the inverse of 13. And that means to put 13 in
For x.
for x. So why don't you give that a try, because it does reduce to a nice number.
It 2.
Yes, it ends up being the square root of 13 plus 3 over 4, which is the square root of 4, which is 2. All right. Any questions on that before we move to composition of functions?
No.
Okay. All right. So let me give you two functions here. Let's say f of x equals 3x squared minus 1, and g of x equals negative x squared minus 2 over 3, like that. And let's say I ask you to find f of g of x. F of g of x. So what this means, it means you start with the inside function, g of x, and you take that g of x and you put it wherever you see an x in the other function. So you are literally, you're literally putting this whole function, which is all of this, in for x. So it's 3, and then you can imagine instead of x, it's minus x squared minus 2 over 3 squared minus 1. Do you kind of see how instead of this x, everything in parentheses is that x from over here?
Yes.
Okay, that's a good start. Like, if you can do that, you're in good shape here. From here, it's an algebra exercise, meaning it's like you're just using things you've already learned to be able to simplify this. So first thing is to recognize that the top is really in parentheses. So it's really 3 times minus x squared minus 2 squared over 3 squared, like that. This square applies to the top and the bottom. Is that okay?
Yes.
All right. Bottom here becomes 9. It's interesting. So it's 3 over 9. But then this minus x squared minus 2 squared, what that really is minus x squared minus 2 times minus x squared minus 2, like that. So let me color code this in case you want to kind of see that later. It's like, okay, there we go. Those are the same. Make sure you write it out that way. The next thing here is to FOIL. So first times the first, for outside ones, inside ones, last ones. So minus x squared times minus x squared, the f there. Sometimes people call this the rainbow. Becomes positive x to the fourth. The two negatives cancel. X squared times x squared, you add the exponents. Then the outside is minus x squared times minus 2, so plus 2x squared. The inside is plus 2x squared, and then the last is minus 2 times minus 2, which is plus 4. Is that okay?
Yes.
So then typically you can combine the O and the I. So this becomes x to the fourth plus 4x squared plus 4. And then 3/9 is really 1/3, and that's on the outside here. And don't forget to bring down this minus 1. And then you distribute this in, so it becomes 1/3 x to the fourth plus 4/3 x squared plus 4/3 minus 1. And then again, you combine like terms. So this becomes 3/3 minus 1 becomes 3/3 is the same denominator, which is 1/3. It looked like your teacher really liked to have fractions and kind of odd things in there. Does that look right to you from what you're seeing in class?
Yeah.
Okay. So that is the final answer. The key though is recognizing from the start which one goes into the other, because the order matters. So let's do it the other way. Because you could actually go in either direction here. So you can actually do g of f of x, which if you look back in your notes, you'll see that it's the flip. F of x is now the inside function. So you're taking this right here and putting it in wherever you see an x. And you know, sometimes one way is easier than another, but you're treating this x like it's in parentheses minus 3x squared minus 1 squared minus 2 all over 3 like that. So just scan that over, say, okay, I see where that is, that goes in there, I see where the negative is, minus, like you want to make sure you see it all so that you're not looking back at your notes wondering, well, how did he do that?
Yeah.
And I think you can see that here. All right, now that's the squared here becomes just like in the previous one we did, you have to multiply these together. So this right here becomes these two. You can see that. And again, you have to FOIL. All right, so 3x squared times 3x squared is 9x to the fourth. 3x squared times -1 is minus 3x squared. Then it's minus 3x squared. Minus 1 times -1 is plus 1. But you have to bring that negative down. -2 all over 3. Okay, next thing is to distribute the negative in. So it becomes minus 9x to the fourth plus 3x squared plus 3x squared minus 1 minus 2 all over 3. And then you combine like terms. You know what I mean by that here?
Yes.
All right. So the what I'm seeing as a like term is, well, we need to combine a couple things at the first. So it's minus 9x to the fourth plus 6x squared minus 3. And then you can actually divide each of these by 3. Believe it or not, it all worked out. I don't, I didn't intend that, but it did work. Like that. And then that becomes minus 3x to the fourth plus 2x squared minus 1. Any questions on that?
No, thank you.
Okay, so we're pretty much out of time for today. What's kind of your game plan to study review between now and the test tomorrow?
I wrote everything we just did. I did on a different page or like different